All right, everyone, welcome to the episode 18 of the RiSWP Mentorship series. Thank you all for joining us. So today's episode is hosted by the Smart Water Networks Forum and by the Rising Smart Water Professionals, or RiSWP, SWAN's Young Professional Arm. Just before we get into kind of our main topic today, just a few quick announcements and some recaps of really exciting events we've had going on here at SWAN. So as many of you know, or some of you might not know, we just passed our 13th annual conference, which this year took place in Glasgow in Scotland. It was a really exciting event. We had close to 400 people joining us in person with a really, really nice show of our young professionals, lots of excitement, great events. So just a few exciting things that happened at the conference that we want to share with you guys, our audience. So first of all, a big shout out to the RiSWP Leadership Team Chair, Billy Rossman from Hazen and Sawyer, who was presented an Outstanding Leadership Award at the conference. Thank you so much, Billy, for everything you do for our community, for helping to grow RiSWP into what it is. We look forward to watching your continued success, both with RiSWP and in your career. So thanks again, and big round of applause for Billy.
Yeah, thanks so much, Sandy. Really appreciate it.
Yeah, thank you. Next up, we also had a contest before the conference, and we gave away a raffle ticket. So congratulations to Osama Hanini for his outstanding entry. We hope that you enjoyed the conference, and we look forward to having you with us at future RiSWP events and SWAN events as well. And then lastly, we just wanted to, have one of the participants of the conference share their insights. I can talk all day about what we did from the conference, but I think it would be better for you to hear from one of our young professionals, one of our RiSWP ambassadors, and Kedar also, joined us as a volunteer at the conference. So Kedar from Kitos is here to share a little bit about his experience at the conference. So I'm going to hand it over to him now.
Yeah, thanks, Andy. And so my name is Kedar. I'm a staff data scientist at Kitos, and I'm also one of the RiSWP ambassadors this year. So what's funny is when I was trying to decide how to share my thoughts, this is exactly the meme that I ended up going back to. I remember, Sandy, you shared this on our platform, and this is exactly how I felt on my first day. So I was a duck waddling amongst all of these giant swans, and this was my first conference, and it seemed like everyone knew what they were doing, right? But fortunately, it didn't take long for me to get out of that feeling, because the conference was so inclusive for a young professional like me. I was able to engage in all of these really interesting, interactive discussions with all of the experts, the panel, and yeah, fortunately for me, this feeling didn't last long. And we had a wonderful set of conversations around technologies like digital twins, AI and machine learning, innovation, scaling, everything that the utilities are doing. But for me, there were three recurring themes that really stuck with me. First of all, it's always about the data. So that's my biggest takeaway. And I'm glad to have found that as a data scientist myself. But when I was there, I could see people living data in a way. So the first takeaway was always follow the data. Data is the thread that ties all of our project life cycles and different stages of our work. And especially when in a complex system like a utility, it really makes so much sense to follow the data, and it gives you a great sense of your role, your responsibilities, and how you can bring in the most value. So lesson number one for me, always follow the data. Lesson number two is all about the people. Always build for them, not to them. This was a quote by Dr. Athena Zito from Scottish Water, and brilliantly summarizes everything that most of the conversations were discussing. So people are at the center of everything that we do, and a great business strategy is the one that focuses on the people at the center, people-centric strategy. So that was my second takeaway. And finally, it was all about innovation. So innovation is the third takeaway, and I was confused whether to call it innovation or risk, because innovation and risk, both of them go so hand in hand. Because innovation at its core is planning for uncertainty. And for example, all of the discussions that we had, let's say about AI, we never know where technologies like AI and blockchain will be in a year from now, let alone a few years from now. So to be a great innovator, it's always better to plan for uncertainty. So again, my three lessons: always follow the data. It's all about the people and innovation. And we had a lot of fun at the conference. I was there in person, and I'm really looking forward to the next one. For me, it was also about meeting a bunch of people. Some of them are here on this call, so I had a great privilege meeting all of them, and I can't wait for the next iteration. I'm hoping to seeing more of you there. Thank you. Thanks, Andy.
Thank you. Thank you, Kedar, for sharing those really awesome insights. We were super happy to have you at the conference, as well as all the other young professionals and members of the leadership team and the ambassador squad that joined us. And we hope to see even more of you at our next, SWAN event and in-person events. So now for the main event for tonight that you've all been waiting for. So I'm going to pass it over to the host of the mentorship series, to Jade.
Yeah, thanks, Sandy. Hi, everyone. I'm Jade. I work for Jacobs Engineering, and I'm based out of the Bay Area in the US. So what is the Mentor series about? So we're a bi-monthly, interactive digital interview series with the world's leading smart water sector professionals. So this is just a chance to just have sort of an informal mentorship session, and we do record these interviews. So even if you want to go back and check out what someone said and you're trying to remember it, you can just go on our YouTube page and you can see, I think we have 17 episodes so far. This is our 18th episode. So before we begin, I just want to ask everyone to introduce yourself in the chat. And then feel free, as we're going through this whole discussion, to put down any questions you have in the Q&A box, and then we'll ask it in the Q&A session towards the end. So now I would like to introduce our three great guests for today. Our first mentor is Javad. Javad is the principal data scientist at Hazen and Sawyer. He brings 14 years of experience in data science to the table, with a specialization in the water industry. He holds a master's degree in computer science and a PhD in environmental engineering. He has proven expertise in statistics, machine learning, cloud deployment technologies, and has made significant contributions to the field through his peer-reviewed publications and conference presentations. So currently he chairs the AWWA Information Management and Technology Research Committee, and is set to become an adjunct assistant professor at the University of North Carolina, Chapel Hill. Next, we have Gayathri. Gayathri is an award-winning scientist, engineer, and entrepreneur who has been pioneering the integration of clean technology and data science since 2003 in organizations like Argonne National Lab, Facebook, and the Smithsonian Institute. So she was recognized by the US National Academies of Science and Engineering for innovation in environmental research, and then was later invited by the Obama White House to participate in the first conference on innovation in clean technology and big data. So as an engineer, data scientist, and leader at several Silicon Valley startups, she has built and led the creation of infrastructure and algorithms to apply machine learning in water, agriculture, and energy systems. She is currently the CEO of Ecoformatics, an education startup that teaches machine learning and data science skills to professionals in clean technology. And lastly, we have Mason. Mason is the CEO and co-founder of Confluency, a water engineering startup using optimization and advanced analytics to identify cost-effective solutions for water and wastewater network challenges. Mason has a background in hydraulic modeling and system optimization, and has worked on projects across the United States to leverage data analytics and optimization to enable whole system insights into complex operational and capital planning needs. Mason believes that drinking coffee and coding is the perfect combination any time of day or night. And one of his only hard and fast rules in life is don't use VBA. So welcome all of our guests. Great, we have a great panel today. I guess I want to start with a question for the whole panel to get started, which is, do you remember the first bit of code that you wrote? What motivated you to start learning to code, and how did you learn to code? So I think we'll start with Javad.
Sure. So I first got into coding back when I was doing my undergraduate at environmental engineering. I remember writing the super basic Pascal script, that language that I was using, to do matrix multiplication. It was wild seeing how a piece of code could unravel complex stuff, make sense of heap of the data, and take care of tedious tasks. I guess what really got me to dive deeper into coding was realizing that just how much it matters in engineering, especially in my field, that a piece of code can automate and solve a problem and make it much more straightforward by just doing it manually or using Excel. So that was my main motivation to start learning the code, and then I kind of moved to learn some online courses, attend some classes, some hackathons, and also kind of volunteer myself in graduate school and choose to be teaching assistant for MATLAB programming. And all of those kind of helped me to learn code more and more.
Nice. How about you, Gayathri?
Well, I'll say that I got dragged into coding, kicking and screaming. You had to take coding as an undergraduate in engineering college in India. So I took coding classes, didn't really see the point, frankly, of writing several of the programs that we were doing for classes, and frankly found civil engineering and environmental engineering much more fun, traditional hard engineering skills. Came to the US for my master's and then started working on optimization and figuring out how to help stakeholders understand trade-offs between different environmental remediation systems, between different water treatment options, and realized that coding was actually fun and useful and not just a waste of time. So I remember the first piece of code that I wrote, and I also remember thinking that the computer was very stupid, which it is for the most part. But now when you look at all the advances that are happening, it's one of the most critical skills in actually making things useful in the water sector or in any other clean energy or agriculture or any other environmental sector. So that's nice entry into coding. Did not like it, can't live without it now.
How about you, Mason? Do you have a similar story?
Yeah, well, my dad was a computer programmer, and so I used to like to go into his office, and it was littered with like colorful little note cards and printouts and all this weird hardware and wires. And I was wondering, what the heck is he doing in there? And I tried to get him to teach me how to do it so I could help him, but he didn't think I'd be that helpful. So he thought I should be outside playing. And so it wasn't until high school that I learned to code. I had the fortune to get into like a C++ class, and one of the programs I remember writing there was like where you'd input some text and then convert it to Morse code or something like that. And so it's really fun. It opened up a whole new world. It was a combination of sort of the math and sciencey logic type of thinking, but then how do you structure this? How do you make it so that it's easy to create and maintain? So there's this creative element to it as well. And then when I started at CH in the mid 2000s, CH2M Hill. And that's where I had kind of a pivotal moment. I remember I was working on a project in Kansas City where we had to, whereas an Excel workbook with like 20 different pages where we had to print out the same PDF from the same figure from each of those 20 pages. And I was going to think, this is going to take like 15 minutes to do. I don't want to just do that. So I wonder if I could code this. And so I started Google searching, and then, you know, an hour and a half or 2 hours later, I had the job done. And it wasn't as quick, but it was opened my eyes to what was possible there. And so I tried to avoid doing any repetitive tasks like that ever since.
Nice. Yeah, Yeah, that's a nice thing. I definitely have had the experience of like thinking, hey, I don't want to spend 15 minutes doing this, and then like 3 hours later, I'm like, maybe I should have done that. But it definitely works out because you always have to do it again.
Yeah.
Yeah.
Over time, right?
Right. Yeah. Great. So then I think my first question is to Javad, and we actually got a lot of questions before this episode. So thanks to everyone who asked a question, and I've tried to incorporate them into this like initial phase. So one thing a lot of people asked was, why do I need to code? And like, how important is it for my career that I learn to code? Yeah.
Sure. So I should say not every water industry professional needs to be coding all day, but let's be honest, knowing how to code can make a huge difference in your day-to-day activities. You could speed up your data analysis, teach some boring repetitive tasks, as Mason mentioned, and automate them. You can also build some fancy models for simulation, tweak some software and tools, and make it more kind of automated and kind of get more out of what you're doing. At the beginning, it may take some time, but later on, it kind of with all the tech stuff happening, it's pretty much like useful to have this knowledge. It could be like your secret weapon that you can bring to the table when working with some other colleague, like do the job faster. And I should also suggest that it can seriously ramp up your career and give you an edge over others when you have coding skills. To be honest, we see that nowadays more and more in the jobs that we are posting and the candidates that are coming to for the interview. So it seems that yes, many of current and like professional that work in the industry and current student know that this is useful. So there's no like need to emphasize that more, but yeah, having coding make a difference in general.
Nice. Mason, the next question is to you. There are so many coding languages out there, R, Python, even Excel, and then, all these different areas, platform engineering, data science, UI, UX, machine learning, cloud computing, and endless areas. But we need to start somewhere. So what are some few coding languages or areas of programming that you would recommend, and maybe even not recommend? And then do you have any just simple ideas for like initial projects that someone could get started with?
Yeah, so this is I think there is actually a straightforward and right answer to the main part of this question, like where to start in a coding language. I think Python is the place to start for most all applications. But I'll talk a little bit about why, but then also some reasons why and in what circumstances it may not be the best. But Python is easy to get started with, very powerful. Has a huge amount of libraries specialized for computational and visualization tasks. So the kinds of things that we as engineers need to do, you can do it there. You don't have to invent yourself. Somebody else has already had the problem and figured it out. And there's a strong base to build on. And then there's a really strong community around Python as well. So a lot of sharing in the open source community and across some of the different initiatives and technologies that are out there. So I'd say, get started with Python, and to some extent, it's not many of the things that you will learn and you will struggle with through Python. You would struggle with the same way, or similarly, if you chose a different language like C# or like R or C and C++, those are generally harder. So I would stay away from those unless because you have to manage the memory, but unless you really need to, you need to be a little closer to the metal or performance is really a question, then you think about those kinds of languages. But in general, get started with Python. And so amongst those areas where to focus, I mean, this is kind of what it's why the problem is so interesting and so challenging is there are so many things that you can do. And so I think this gets back to that initial question about, oh, why do you want to code and what's the problem that you're trying to solve, right? We don't need to choose this in the abstract, like I want to learn this visualization library. Like, what are you trying to solve? And then that will sort of lead you in the right direction in terms of where to focus your attention there. But for the types of work that we do, you know, coming from the engineering consulting background, I think a lot of folks on the call are from that background. When you do a lot of file manipulation, data processing, interfacing with other applications and visualization, you know, I think a library like Pandas is a really important part of the toolkit. That's kind of like your Pythonic version of a Excel/database type of mix, and it's very, very powerful. So learning those skills are really good. And then communication is so essential of like what you've done, right? And so you could print out a big text file or a lot of reports, but visualization is such an effective way of communicating that you've done something novel or something that you couldn't have done just doing a manual approach, right? So there's a lot of good visualization libraries out there, Bokeh, Seaborn, Panel, Plotly, Matplotlib. So choose one and, you know, try to work with those around you to become really good at that particular one. We use Plotly at Confluency, just so that we're all sort of standardized around a common one. We don't have to, you know, do a different visualization library for a different project. And this kind of leads to the last point about another reason why Python might not be the right solution in some cases is, what are the people around you using? You know, what's the project already invested in or the code base already in that you may be contributing to, maybe not initially when you're just getting started, but maybe 6 months or a year down the line. If everybody's in your team is sort of focused on a library that's written in C#, well, that would maybe strongly encourage you to maybe start there. But that doesn't mean you have to limit yourself to just one, but think about where you can make an impact, what problem you're trying to solve, and what the people around you are using.
Nice. I really like that. You know, don't focus on just learning coding for the sake of it. Like, you should be trying to solve a problem you actually have. Jawad, I actually saw you nodding a lot while Mason was speaking. Are you a big fan of Python as well?
Yes, definitely.
Nice. How about you, Gayathri? Do you agree? Are there any other aspects of like, you know, starting that initial starting phase that you want to highlight? I mean, after this, I'm also curious, like, so, you know, okay, I want to start learning Python. But what do I do? What do I have to download? What courses should I be looking at? Like, do you have any advice about that kind of stuff?
Well, Jade, the second one is a bit, is slightly leading, but I'll answer the first part of that first, which is, do I think that Python is the most useful? As Mason said, it really depends on what you're trying to do. So if you're trying to work with hydraulic models or a lot of water utility models, many of them are written in Fortran because Fortran is the stable numerical computing language. So if you're working in that space, you should probably start with Fortran, which is fortunately not as messy as C or C++ in terms of the memory, but is still harder than something like R or Python, which you can literally type on your console and start working on. If that said, there's a lot more emphasis these days on Python, and it's a more modern coding language. It gives you more flexibility. It lets you do a lot of different things. So I would pick Python because most of the new technology development is being done in that. So if you want to be at the cutting edge of technology, if you want to be the one with skills, as Jawad said, the one who's unique in your company or unique in the job that you're looking for, I would start with Python. So the second part of your question, which is you've decided to start with Python. So where do you go from there? The quickest and easiest way if you're working with Python is to use Google Colabs. Because if you've got a Google account, you can use Google Colabs for free. And that avoids the whole question of what do you install, how do you install, do the packages and the libraries talk to each other? Because quite often, because it's an open source community, you'll have one library that you'll install that doesn't talk to the other library. So you'll spend a few hours trying to figure out what you've done that's wrong when it's actually the libraries don't talk to each other because the versions are different. So if you want to start without any of that, if you're a beginning coder and you want to start looking at how to build, how to write programs, how to solve your problem, start with Google Colabs, because you can go to the console and start typing it out. So that's my recommendation. Once you get past that, then use Anaconda and install Python. And there are several courses that teach you how to do that. You can Google it. You'll have boot camps and you'll have other free resources that teach you how to install different packages. So for courses and fun stuff, there are quite a few universities that offer certificates. So University of Illinois, Colorado, State University, a couple of Penn State. So some of them offer summer camps and short certificate courses that you can take. They're like any other university program. They are expensive. Sometimes they allow you to, you do get a certificate. They're intensive. So depends on what your time commitment is for that. If you're just looking at getting into coding, you will find several resources online. Coursera has free courses. You can check out some of the data camp and some of the other more common boot camps. I don't often recommend that for anything more than the basics, because those courses are taught from a programming and computer science orientation. So it's for people who want to write code, who want to write software for the tech companies. Not everything that they do there translates to what you're doing in the water industry. And that's where, that's one of the reasons why we started our company, which is taking some of those skills to teach and to teach professionals in the water industry how to actually use things. So yes, you install Python, you're writing a visualization. What happens when your data is, when you have missing data, which happens to a lot of us when sensors get knocked out, or you get data files that are not quite appropriate. How do you solve problems from a water lens, not just from a software lens? And that's a different question to answer. So, long-winded answer to a short question.
Yeah, thanks. I think there's so many different aspects to think about that it's great to just get everything that's in someone's mind about a topic to listen to. Javad, I'm hearing like there are so many different resources, right? You could just like do an actual course, or you could just pick a project at work and Google it and try to hack your way into solving the problem. How should young professionals balance that? Do you have any advice for whether you should take a course or like just do a project at work? What are your thoughts on that?
Sure. So structured learning or online courses, getting a degree from universities, those are great. Those are time consuming, as we all know, and we are busy, but they give us the foundation and the why behind like different things, why a specific algorithm works this way, why this language structure is this way. On the other hand, like hands-on experience give us the opportunity to apply those knowledge to real world scenarios. So the key is to balance these two aspects. I suggest getting the theory from a structured learning. If like we want to apply that, like at least search, read some articles, read some like documents, material related to that topic to get the why behind a specific topic. Like you don't need to kind of go too deep at the beginning, just to understand the basic. If it's a hydraulic modeling, just to understand some general like equations, how like frictions work, how head loss work, those things. Like if you want to do a data-driven modeling, those knowledge come handy later on. And then kind of do some more hands-on experience, try to kind of automate some aspect of that work, if that like kind of a hybrid model of mechanistic and data-driven model, try to kind of automate the data part, bring the data to the model, try to kind of interact with the API to some extent. So all of those things give you kind of both hands-on and also the online or like structured learning aspect of that with time that you allocated for that. It's hard, yeah. It's like we all of us doing full-time job and we trying to transition to this coding, and that's requires some like commitment, but it's doable, yeah. And we can kind of push it, learn it, show the result to our manager, and gradually kind of open up more space for doing more activities like that.
Nice. Yeah. I mean, Jawad, you led perfectly into my next question, which is, where's the time, right? It's hard to learn coding when you have like a full-time job. So Mason, do you have any advice or tips on how to balance like a job with learning new skills like coding?
Yes. I mean, it's hard. At the end of the day, time is the most limited resource, right? So if you're going to get really good at this, you're going to be spending quite a bit of time, and you're going to be spending years to gain a variety of different skills. But that you can actually go from like 0 to 1, like not being a coder, to having your opening up collabs and being able to, solve a particular type of problem in not a huge amount of time. But there's a lot of problems out there. So where do you find the time? Again, thinking that to most folks on the audience, a lot of people coming from the consulting background, I think the more you can make it tied to your day job, so to speak, what you're already spending 40 plus hours a week thinking about, the better. So if you could think maybe 10%, if I could figure out a way to be providing value with 10% of that time, which is maybe helping better structure the data that's already a mess. We've already always seen the kind of the file systems and things that get a little bit out of control after a while, or maybe just streamlining a particular step. So firstly, I think look for project opportunities where you can apply based upon where your skill level is right now or just beyond. The second thing is to figure out ways to get training and get resources from your company to do training, because every water engineering company wants to be doing smart things, to have a smart roster of people that are using the cutting edge technologies to solve hard problems, right? So everybody says that they're, invested in these technologies, but sometimes that can still be a little difficult to get access to that training budget. So just make a case to your manager and be a little bit persistent. This is something that happened actually when I was at Jacobs. We were interested in Power BI, and we just asked a couple times and at the right time, and were able to get a small amount of funding from just a local operations manager. And that was enough just to open the door to that technology into business intelligence platforms. And then from that point on, our office was sort of sprouting Power BI solutions on every project. But it's just like, that's the kind of thing that a little can go a long way. And then maybe the last thing to think about is, again, what are your goals, right? Are you trying to transition into a full-time coding job within the water industry? Are you trying to leapfrog out of the industry? Or are you just trying to use code a little to do your current job a little bit more effectively, right? But go back to where I started. I think if you want to become really strong in this across a number of domains, interacting with your persistent data stores and cloud resources, and maybe parallelizing certain tasks, it's going to take a long time, and you're probably just going to have to bite the bullet. It's going to be some of your own time. So invest in yourself, especially in your earlier days, because that's going to pay off over and over, compound interest from that learning early on in your career. So I'd say don't be limited by the resources you have access to in your existing role. You can find, we all, 9 o'clock, 10 o'clock at night, turn on maybe a Netflix show to unwind. What if you spent an hour or a couple hours a week tackling a particular skill? That's going to pay off and give you a lot more opportunities over the next few years. So there's no way around it. It's a limiting factor, but there's things we can do about it.
Nice. I feel like at least tonight I'm gonna go do something. Yeah, I'd encourage like everyone on the chat to post any questions they have in the chat, and then we can ask it as Q&A at any point. In the meanwhile, I did have a question for Gayathri, which is, are there any like specific challenges or opportunities specifically like for coding with water sector like data? I know you mentioned there are specific issues like the data, there are gaps in the data or something. Do you have anything more to speak about opportunities or data sets maybe that are out there to work on?
Oh, lovely question. Can I take the next 20 minutes? That's about how long it'll take to chat about what you can do with coding and data in the water sector. So the first and simplest questions are, as Mason mentioned, how do you visualize your data? Because when you're working in consulting or you're working with water utilities or any companies, you get a ton of data that you usually put in an Excel spreadsheet and then put it in a graph. Now, when you're starting out coding, and I'll be very frank about this, the part that's going to be the hardest is going from putting things in Excel, where you can do it manually in maybe 5 minutes, to actually writing code that will take you a lot longer the first time around. So, but it's something that you can use multiple times. So once you've written the code and written the script, that's something that the next time you get a file, you just run it through the program and you're done. So it makes you faster in the long term. But there is that first jump where it'll be like, I can do this in 5 minutes. Why do I need to spend 3 hours and write a program and not have it run and get errors and not make it work? Unfortunately, that jump has to be taken. But once it's taken, it opens up this whole set of opportunities. So in the water sector, data visualization is one of them. The second one, if you're thinking about immediate impacts, whether you're in a water company or in a consulting firm that's working with water companies, looking at things like flood inundation. So looking at how you can model, you can look at short-term weather forecasts and model what's happening in the water system for immediate disaster mitigation. If you're working in a water utility, can you look for anomalous data? Can you find the outliers that indicate that something isn't performing well? Can you build these programs that let you do this quickly and efficiently? So those are some of the simplest things that you can get started with. Once you're done with that, the third stage would be, now how do you integrate fun toys like machine learning? How do you integrate neural networks? How do you start combining neural networks with hydrologic models, with water models, to build something that is much more predictive? How do you look at climate change impacts on your water resources? How do you help people conserve water not by being a stalker on Facebook, but by helping to influence behavior through reminders, through reminding people about what your water budget is for the month? Because how many of us have been in a drought, if you're in California, looked at your water bill 2 months later and then realized, oh, I probably could have watered less that week. So those are all the problems that can be solved. Just off the top of my head. I'm sure Javad and Mason have many more as well.
Jawad and Mason, do you have more? Jawad, do you have any other examples or like, things that should be worked on in the water sector?
It's like challenges and opportunities for beginner. That's the. I think overall data visualization is usually needed for kind of communication. So you don't need to start with predictive modeling and just focus on understand your data that right now you're dealing better. So if you're doing it in the past in Excel, now use a piece of code to do plotting for all of those parameters that you have in your data set instead of just doing one by one in an Excel chart. Try to apply some like moving average on top of that, some like cumulative average. All of those things are some opportunities for beginner coders to get more out of what they are doing in a faster rate. It may take at the first time, it may take more time to develop that code, but then you can use it on all data set that you have. So that's a good place to start. And it gives you also the opportunity to present that to your manager and kind of get more support out of it. Because the predictive modeling, the final result is just a prediction, but there's lots of work behind that you have to do to reach to that point. But visualization is kind of a good start and easy to get some result out of it. So I can say that as one example for opportunities in this sector for beginners.
Nice. Yeah, definitely seems like data visualization is kind of standing out. And because I think it just takes a couple of lines of code. And just from my experience, I know you can do so much more visualization with like a coding language than you could with other, just like the regular software that we have. Mason, we have a question for you from the chat. Boytomelo asks, you mentioned in your intro to stay away from VBA. Why?
Okay, so this is my opinion. I could be wrong, but I actually do think I'm right about this, and that this is a pretty good rule to stay by, except in that case where if you're working on a project where there's an existing code base that works and your team needs you to add a functionality to it, you've got to work with what you have, right? And so you can work with it. But why is VBA bad? And first, I want to say I love Excel, and I even love Microsoft Access, which is a database that a lot of people snub their nose at. So I really like the ecosystem there. But the problems with VBA are basically two in my mind. Firstly, it's really hard to manage that code base, right? Because it's in the code behind of the Excel worksheets or the workbook, and it doesn't get into a version controlled system, which makes it really hard to collaborate with other team members and add functionality and to track changes over time. So you're kind of left with the way that we do versioning in Excel with different, numbers, names of the workbooks and things like that. But one topic we haven't brought up here is version control, which I would say there's a program called Git, G-I-T, which is the way that software people manage code as part of teams. And this is also a game changer. And I think it should be maybe not in your first few steps, but within the first few months, becoming familiar with Git. And that's really hard to use with the code behind in VBA. The second thing is that it really blurs the boundary between your user input and your computation. That's why we like Excel, is because here's the data, I'm making these changes and I see the output right there. But when you get into coding, there's principles like separation of concerns, which you can read more about and learn about as you get in there, is like, I want to really modularize the parts of my solution that are interacting with the data ingestion, the data transformation, the analytics, and the output. I want those to be quite separate and to be pretty clear boundaries, so I can change one thing and not have an unexpected effect somewhere else. And Excel, just the way it is, it's your one-stop shop for your data, doing everything you want to do, getting the output. And we've all seen examples of very nice Excel workbooks, and perhaps more examples of workbooks that got a little bit out of our control. And so code can just make that even worse. So it violates that separation of concerns property. So difficulty with sharing and team collaboration at speed, and also violation of separation of concerns.
Got it. Very, very insightful. I see another question which I don't like. It has some thumbs up. I'd also put a thumbs up because I'm obsessed with this. But you know, a lot of people have seen ChatGPT and all these like new large language models that a lot of people are using to help them learn how to code. So maybe I'll ask Gayathri this question. How do you see all these LLMs impacting learning to code? And do you have any advice for how to work with these tools?
Yes. So just out of curiosity, how many people have actually played with ChatGPT in this room? Have you ever tried asking it simple questions like, what has the weather been in a certain area? Yeah, so quite a few people. Now, the fun part is that ChatGPT was built off of code. So large language models are essentially neural network based. They're machine learning models. As machine learning models, they depend on the training data. They depend on the data that you use to teach the model, teach the algorithm. The fun part, when the data is properly trained and you have a language that the LLM is familiar with, it can provide you with useful resources. It's like typing in a Google search box. The not so fun part is when it gives you results that don't make sense. It points you to a library that maybe existed 5 years ago and does not exist now. So you will spend a ton of time trying to figure out where that library went. Sometimes, so if you are learning how to code, I would say it's better practice if you're not familiar with it, to do the work, look at the documentation, do Google searches and look at where things are before you go directly to large learning models. Where large learning models are helpful is after you've learned to code and you're doing things like, okay, I don't remember the syntax. I don't remember exactly how to write that. So you start typing things in and it fills it up. But you have enough knowledge at that point to say that, okay, this is actually right. If you depend on LLMs to teach you, I'm afraid you're going to be spending a lot of time spinning your wheels. So it's not a magic bullet, and it doesn't always give you the right answer.
That's great. I mean, I think yeah. So you know, at Jacobs we have like a whole group that just talks about all of this, and almost everyone is like, it's great, but then there's always like a disclaimer, and they said, I tried to search for something like for the basic stuff, it's great, but for the more like niche uses, it always gives like the wrong information. And then I think even personally, I've had the experience of I asked it for something and it gave me an answer. When I tried to think of it, I came up with a better answer, but that's because I'm still learning. And I just don't know everything. So yeah, that's good advice for sure. Kedar had a good question. Kedar, do you want to ask the question yourself?
Yeah, for sure. So I know that contributing to open source, via open source GitHub projects, GitLab project, and so on, it is one way that helped me start to code. I just wanted to know what all of your opinions are about that. And then the second part of that question is, do you think the water industry suffers from a lack of open source contribution? And is there something that we as individual developers can do about it?
Good question. I don't know who wants to answer this. Jawad, would you be interested?
Sure. Yeah, definitely. If you have time to do those type of contribution, why not? That's give you opportunity to work on a real world experience with a diverse team, learning from others, also review others' code and other people review your code, give you feedback. team working, collaboration, all of those are the benefit of working on that activities. However, it requires your time. So you can kind of balance, is that a good way to kind of go to this environment, to this coding, learning opportunities, or just doing my job and developing codes related to my job and then use that to kind of improve my portfolio in this region. In terms of your second question, open source code for water industry, I think it's coming gradually. Water industry, as we all know, kind of there's a lag in comparison with other industries. So we will see more open source. For example, Billy as well is here. We are using a Python package called Pickles, developed by some national labs and EPA. So it's pretty good package for data quality check, outliers. Those are kind of examples that like we can see coming or already developed. So we will have more and more in the water industry as well.
Yeah, I would jump in there. I agree with what Javad said, and I guess one thing I'll mention too is that my experience is that open source communities are really welcoming and inviting, and many have sort of ways of kind of easing people into the waters, right? Because you how can you make a contribution? So many of these projects, they need help. They need people who are motivated and kind of understand the problem that's trying to be solved. So I think in general, you'll find some receptivity there. And maybe one of the things that we haven't mentioned quite so much in this call is learning from others, like the people around you. I guess that's something I probably should have mentioned in my intro too, is that like I would bother the person up the hall, you know, not too often, but just a little bit, right? And because there's a lot of folks in all of our companies and in this community that know a lot of things and actually like to share their knowledge. And so the open source avenue can be one angle for that, but don't find people who you can learn from who are a couple steps ahead, and ask them questions as well, whether that be through an open source project or through your organizations.
Nice. This is great. And I wish we could just talk about all these questions forever. Unfortunately, I think we're running out of time at this point. So I guess I just want to end maybe with like a quick, couple of sentences from like each of you, which was like, what is one thing that if like you wanted people to take away one thing from this call, like what is the one bit of advice you would offer to young professionals about programming? Gayathri, I'd start with you.
Say the one bit of advice that I'd like everyone to take away. If you're starting to code, don't be afraid of making mistakes. It's code. You're not deploying it in a water treatment plant just yet. You're not going to impact people's lives just yet. So it's okay to make the mistakes. It's okay to have it turn crazy and give you results that you don't expect, because that's how you're going to learn. And the other bit of advice is that even if it seems hard, this is one skill that I think we will need in the future, because both from what I've been doing with my experience with other startups and other companies who are looking at the water sector and at smart water, the biggest gap is the lack of people with enough knowledge of coding and enough knowledge of the water sector to actually make meaningful solutions, to actually build things that make sense. And that's something that if you are in this field, and you start doing this, you're going to have a heads up in 10 years' time.
Nice. Javad, do you have any parting bits of advice?
Sure, I definitely agree with Gayathri on those comments. And I can add that kind of embrace challenges and kind of join some hackathons if you have time. I did that a lot in my graduate school. It ended up to even like some startup companies that I co-founded. So those challenges, problems that kind of out of my day-to-day research activities give me opportunity to learn more, kind of have a better network in general, and stay kind of up to date with what is happening in different fields, because those type of event hackathons, usually they are very good in terms of like understanding some new concepts, some new ideas, and kind of see how other people are thinking about their development of a prototype or some like minimum viable product, for example. So embrace challenges, solving problems, seek feedback from others, and even like try to find a mentor, kind of somebody who is kind of doing those things. So these are some advice that I can provide.
Nice. Yeah, the people aspect is important. Mason, you can end this.
Yeah, great insights to both of you. I think, figure out what your sort of unique perspective is, or what you have access to from the water side and what you're trying to solve. And then kind of take this attitude of sort of making relentless progress in that right direction. So as Gayathri said, what we have a lack of is the people that can cross over between the technical computational space and the water domain space. So just by bridging that gap and understanding the problem, you can do a tremendous amount. And so don't underestimate like the value of the knowledge that you've been building up in these other avenues, because we really understand the problem really well. That means we don't have to spend time solving things that aren't the actual problem. So leverage your strength and then look for ways to express those in ways that actually provide value to your boss and your teammates, so that you're making sure you're solving problems that actually matter.
This is great. I want to thank all of you, all the guests and all the participants for joining. It's been super helpful to listen to everyone, and also quite inspiring for me personally. To everyone who attended the call, please give us feedback on our episodes. Let us know if there are guests or topics that you want to hear next, and we'll work on setting it up. So yeah, Sandy, do you have any other things to say?
No, I think you got it all covered. Jade, thank you so much. That was a fantastic panel. Thank you to our panelists for sharing your insights. I know I definitely took a lot away from it. And just so you guys know, the recording will be shared with all of you, and we'll also be sharing it in our LinkedIn group with our wider RiSWP community. So thanks again, everyone. It was really, really great. Have a great day, everyone.
Thanks.
Thank you.
Thanks,
Thank you.
Sandy.
Thanks, everyone.